Good morning, everybody. Myself Pradna from Bangalore Institute of Technology, here to explain about the simulation of site-to-site VPN connection between two offices using Cisco Packet Tracer. First, let us look into the introduction to virtual private networks (VPNs). A virtual private network is a technology that creates a secure, encrypted communication tunnel over a public network such as the Internet. It allows geographically separated offices or users to exchange data securely as if they were connected to a VPN. Organizations with multiple branches office commonly use site-to-site VPNs to ensure secure communication, protect sensitive information from unauthorized access, and reduce the cost of maintaining dedicated leased lines. Let us look into the problem statement. Let us look into the introduction of virtual private networks. Key features of VPN are provides a secure communication over public networks, encrypts data to maintain confidentiality, authenticates communicating devices, ensures data integrity during transmission, reduces networking cost compared to private leased lines. Applications are connecting to branch offices securely, remote employee access, secure transfer of organizational data, business to business communication. Now, let us look into the problem statement. Organizations with multiple offices need exchange to sensitive information over internet. However, data transmitted through public networks is vulnerable to various security threats such as unauthorized access, data interception, eavesdropping, and cyber attacks. Using dedicated private communication links can provide security but involves high installation and maintenance cost. Therefore, there is a need for a secure and cost efficient solution that enables office in different locations to communicate safely over existing internet interface. Some of the challenges are data can be intercepted during transmission, lack of confidentiality in public networks, risk of unauthorized access to organizational information, high cost of dedicated leased line connections, need for secure communication between geographically separated offices. Proposed solution: implement a side to side VPN that creates an encrypted tunnel between two office networks, ensuring secure data transmission, user authentication, data confidentiality, and integrity. Cost efficiency connectivity over the internet. Expected outcome: a successful VPN connection will allow devices in both offices to communicate securely as though they are part of the same virtual private network, while protecting data from other external threats. Let us look into the objectives of this project. The primary object of this project is to simulate a secure site to site VPN connection between two geographically separated offices using Cisco Packet Tracer and demonstrate secure communication over a public network. Specific objectives: design a network topology representing two office locations, configure routers to establish a VPN tunnel between the offices, implement IPsec based encryption for secure data transmission, enable secure communication through the internet, verify connectivity between the two offices' network using network testing tools, demonstrate how VPN technologies protect organizational data from unauthorized access. Some of the project goals are to establish secure communication between Office A and Office B, ensure confidentiality through data encryption, provides authentication between VPN gateways, maintain data integrity during transmission, reduce communication cost compared to dedicated private networks. Expected result after successful VPN configuration, devices in both offices should be able to communicate securely through an encrypted tunnel, ensuring safe and reliable data exchange across the internet. Network architecture and system design. Network architecture. The proposed system consists of two geographically separated office networks connected through the internet. Each office contains a local area network LAN connected to a router that acts as a VPN gateway. These routers establish a IPsec VPN tunnel, allowing secure communication between the offices. Some of the components used are two IPsec PCs, one in each office, two switches, two routers, VPN gateways, internet or cloud network, IPsec VPN tunnel. This is the architectural design of site-to-site VPN architecture. Office A has PC1 with the address of 192.168.1.10 and has switch A and a router A, and it is connected through internet or IPsec VPN tunnel, which has router B, VPN gateway, switch B, and PC2. Here are Office A network details: LAN network and LAN gateway and VPN IP router A. Office B LAN network, LAN gateway, and WAN IP are given in the picture. Let us look into the working principle of this. The data originates from a device in Office A. The router A encrypts the data using IPsec. The encrypted data travels through the public internet. The router B decrypts the received data. The data is delivered securely through the destination office device in Office B. The same process occurs for communication Office B. Benefits of this architecture are secure communication over public networks, protection against unauthorized access, cost efficient alternatives to leased lines, scalable for connecting multiple branch office, ensures confidentiality, integrity, and authentication of transmigrated data. Here is the IP addressing scheme and VPN configurations. IP addressing scheme where a device PC1 with an interface NIC and IP address of 192.168.1.10 and a subnet mask of 255.250.0. Router A has LAN interface GO/O of 192.168.1.1 and a subnet mask as same as the above. Router A as GOI interface and a subnet mask of class D. Router B has WAN interface and an IP address of 10.0.2. Router B has LAN interface of GO0 and 192.168.2.1. PC2 has no interface and is 192.168.2.10. And these are the VPN configuration parameters. VPN type over here is site-to-site VPN. Security protocol is IPsec. Encryption algorithm is advanced encryption standard. Hashing algorithm is SHA, secure hashing algorithm. Authentication method is pre-shared key. Tunnel mode is IPsec tunnel mode. These are the other parameters that have been required. VPN establishment process. Router A, router B authenticate each other using pre-shared key. An IPsec tunnel is established between the routers. The data packets are encrypted before transmission. Encrypted packets travel securely through the internet. Receiving router delays, decrypts, and packets are forwarded them to the destination network. Benefits of VPN configuration. Secure transmission of confidential data, protecting against eavesdropping and interception. Authentication of communicating devices, reliable communication between remote offices. VPN tunnel establishment process. A side-to-side VPN creates a secure and encrypted tunnel between two remote office networks. Before data encryption begins, both VPN gateways authenticate each other and negotiate security parameters. The step-by-step process is the step one is authentication. Router A and router B verify each other's identity using pre-shared key. Unauthorized devices are denied access. Security negotiation is the second step. VPN gateways agree on encryption and hashing algorithms. IPsec security parameters are established. Step 3 is tunnel creation. An encrypted IPsec tunnel is created through the public internet. All communication offices between offices passes through this secure tunnel. Secure data transmission. Data packets are encrypted before leaving the source office. Encrypted packets travel through the internet. The destination router decrypts the packets and forward them to the target device. Secure communication. Users in both office communicate securely. Data confidentiality, integrity, and authentication are maintained. Security features provided confidentiality through AES encryption, data integrity through SHA hashing, and authentication using pre shared keys. Secure tunnel using IPsec protocol. Simulation results and testing. VPN configuration was successfully implemented in Cisco Packet Tracer. After establishing the IPsec VPN tunnel, device located in different offices were able to communicate securely through the public internet. Connection test. Ping requests were sent from PC1 to PC2. Successful replies confirmed network connectivity. VPN tunnel verification. VPN tunnel status was checked on both routers. VPN associations were successfully established. This is the pictorial representation of this simulation, which will be looking at the last. Let us look into the advantages of VPN. Key advantages are enhanced security, encrypts data before transmission, provides sensitive information from unauthorized access, reduces the risk of cyber attacks and data breaches, cost efficient solution, eliminates the need for expensive leased lines, utilizes existing internet infrastructure, reduces networking and maintenance cost, secure remote connectivity. enables communication between multiple branch offices, supports secure exchange of organizational data, ensures data is not altered during transmission, uses hashing algorithms to verify packet integrity, authentication, verifies the identity of communicating devices, prevents unauthorized access to the network. Conclusion and future scope. The project successfully simulated the site-to-site VPN connection between two offices using Cisco Packet Tracer. An IPsec VPN tunnel was established between two routers, enabling secure communication over a public network. The implementation demonstrated how VPN technologies provided a secure communication, data confidentiality through encryption, authentication between VPN gateways, data integrity during transmission, cost effective connectivity between the remote offices. The simulation verified successful communication between object A and object B while ensuring the data remain protected from unauthorized access. Thank you. Now let us look into the implementation of this particular project. For this, we are using a Cisco packet tracer where, as instructed in the PPT, we are using two end devices PCPT, which has a distinct number of PC0, and PCPT, which has a distinct number of PC1. Here we have two switches, switch 0 and switch 1. The switch 0 has 2960 TT, 24 TT, and switch 1 has 2960 24 TT. The router 0 2911 and router 1 of 2911 is given and is connected using copper straight wire. The next step involves configuration of PC01. In configuration, I have already configured it to the IPv4 address of 192.168.1.10 and the subnet mask of this. And it also has a default gateway of 168.1.1. Let us look into the configuration of PCPT PC1. The IPv4 address of this has been given in such a way, and the default gateway is also given. Now, each of the routers, here the switch 0 has the CLI configuration already done. And here the switch 1 also has the CLI configurations. Now when we start the simulation, the packets are provided in such a way. Now in router, if we want to ping a packet, for example, if we ping over here, then the packet is being transmitted. It is sending the packet, and if you look at this packet is sent from router 0 to router 1. It is then sent back to the router. This is the simulation of VPN network.